Okay, luckily the dog is fine. She came as soon as I called her. I don't know what she was barking at. I was afraid she was about to go toe to toe with a bear. But anyway, she's safe. She's inside. The door is shut. So hopefully there won't be any interruptions to this video. All right, for topic 6, we're going to look at solving linear inequalities with unusual solution sets. It's kind of a funny way to word this, but when you're solving linear equations, remember how we had conditional equations, we had contradiction equations, and we had identity equations. Conditional equations were kind of like the typical equation that had just a single solution. Contradictions were the equations that had no solution. And then identities were the equation where x could be all real numbers. We have a similar situation that can arise with inequalities, okay? So I have just a quick recall statement. So I say, recall when solving linear equations in one variable, there were special equations that had unusual solutions. The same can be said for linear inequalities in one variable. And just to be super, super clear, those unusual solutions were contradictions that had no solution, or you could have identities that have infinitely many solutions. So x could be all real numbers. So infinitely, I think I squeezed it in there. It says infinitely many solutions. Okay. So those are those unusual solutions. And you'll have something similar here. You're going to have a situation where there's no solution. You're going to have a situation where like everything on the number line works. Okay. So example 6 says solve each inequality, write the answer in interval notation, and then graph the solution. Okay. So we're going to start with 4 times x plus 2 is greater than 4x plus 15. So the first thing I want to do is distribute. So 4 times x is 4x. 4 times 2 is 8, and then just rewrite the rest of the inequality. So greater than 4x plus 15. Now, one thing that drives me insane about teaching this chapter, like the linear equations in one variable and the linear inequalities in one variable, is when students have these unusual solution sets, they don't finish the solving process. I want you all to be thorough mathematicians and I want you to finish the process. So at this point in time, you can tell something's going to happen because our variable terms are the same, but make it happen. Go all the way through the process. So Winnie June, ma'am, it's a car. Anyway, so what we want to do is we want to get the 4x, Winnie. Okay, so what we want to do is we want to get the 4x from the right. We want to move it to the left. So we've got a positive 4x. How would I move a positive 4x? Well, I would subtract it. So I want to subtract 4x from both sides. So on the left, be careful here. This is a really common mistake. What is 4x minus 4x? Well, 4x minus itself is 0. So I'm going to actually write it this time. So we get 0 plus 8 is greater than, well, 4x minus 4x is still 0. So we get 0 plus 15. 0 plus 8 is 8. And then 0 plus 15 is 15. So then we have to ask ourselves, is this true? Or she's trying so hard to be a good girl and she is losing her mind. Is this true or false? Winnie June, please stop. Mama's working. So is 8 greater than 15? And the answer is no. This is absolutely false. 8 is not bigger than 15. So this is a false statement. And a false statement indicates no solution. Okay, Winnie June. Apologies. All right, let's go back to the worksheet. Okay, so basically we should just kind of catch us back up. We distributed, we moved the 4 from the right to the left, and what ended up happening was all of the variables canceled out, and we were left with a false statement. 8 is not greater than 15, okay? So a false statement indicates no solution. Now, here's the deal. The directions told us to write our answer in interval notation and then to graph it. Well, if you don't have a solution, there is no interval. Okay, so no interval notation for no solution. All right. And then if we were to graph it, we would just do a naked empty number line. So I'm going to put empty number line for no solution. Okay, so the good news is if you have a situation with an inequality where there's no solution, it's pretty easy because there's no interval notation. There'd be no set builder notation, and then the graph is just a naked empty number line. All right, let's look at part B. So for part B, the first thing I want to do is distribute. So I'm going to distribute 3 on the left. So I get 3 times x times, or not times, but plus 3 times 1, so plus 3. And then that's greater than or equal to 2x plus 1 plus x. Now, once you distribute, you then want to simplify on the left, simplify on the right. The left-hand side is as simple as it's going to get. I have a single variable term and a single constant term. The right-hand side, however, I can clean up a little bit. So on the right-hand side, I have 2 variable terms. I have 2x plus x. So 2x plus 1x is just 3x. So I have 3x plus 3 on the left. And then on the right, I have 3x plus 1. Okay, and again, I told you this before my dog went gonzo. It drives me nuts when students don't finish this process. I know you understand what's going on. Like, I get it. Like, I get it. We can see at this point something's going to happen, but make it happen. Be thorough, be complete. Math is very formal, very precise. We have to do all of the steps. You can't just stop in the middle of a process and be like, oh, I get it. Let's move on. Finish it. Okay. So that means we want to subtract 3x from both sides of the inequality. 3x minus 3x is 0. I'm going to write it down. I'm going to write it down again this time. So 0 plus 3. And then on the right-hand side, 3x minus 3x again is 0. So I get 0 plus 1. Well, when I simplify, I get 3 is greater than or equal to 1. So again, is this true or false? You have to stop and think about it a little bit more. Like when you're dealing with an equation, it's really easy to see if you have a true statement or a false statement. With an inequality, like really stop, tap the brakes and be like, is this true or is this false? Is 3 bigger than 1? For sure. So we would say that this is true. And a true statement indicates that x is all real numbers. You don't want to say infinitely many solutions here because all inequalities have infinitely many solutions. In this case, we're saying like legitimately the entire number line works, okay? So you really do want to put x is all real numbers, okay? All right, so for an interval and a graph, let's look at it. So we have our graph and we can graph the whole thing. Everything works. And then for the interval, we would just say negative to positive infinity. So I want to put a little note here, graph the whole number line. Or I don't want to say graph, I'm going to say include the whole number line. That'll be better. So include the whole number line. All right. And there you have it. So that is solving linear inequalities where you have those unusual solutions. I am deeply sorry for my dog getting upset. I feel like something is outside. There might actually be a bear outside because she is like losing her mind tonight. Like even behind me, I can hear her doing that like subtle like growl. I make these videos in the evenings because hopefully she'll settle down, but tonight was just not in my favor, but I needed to like just finish it, okay, because I've got to get to bed. So there you have it. Those are the inequalities with the weird solutions. And I think last up is just an application maybe. Ooh, no, I forgot. We've got 3-part inequalities and then an application. So 2 more videos and then we're done with another super long section.